Chemical reactions.
Chapter 6.
Hey guys, my name is Tina.
My name is Carmen. And my name is Cynthia.
Today we have a video for you guys on chemical reactions.
Yeah, and our video is going to be amazing, so you have to watch it. And the video starts in 3,
2,
1, action!
So our objectives for today, we're going to identify different types of chemical reactions. So there are combustion, redox, synthesis, precipitation, decomposition, single and double replacement, and photosynthesis. After that, we're going to learn how to balance different chemical equations and conduct a very interesting experiment with baking soda and vinegar, which is an acid-base reaction. For key terms, we have products, reactions, coefficients, and chemical reaction.
Reactants are substances that undergo a change in a chemical reaction. Products are species formed in a chemical reaction. Coefficients are number in front of species in a chemical reaction. Chemical reactions are processes where the reactants convert to products. Atoms of elements rearrange themselves to form a new substance. My name is Cynthia, and I'm going to teach you about this reaction. This is a synthesis reaction. Nitrogen gas and hydrogen gas react to form ammonia. This is also called the Haber process. When you are balancing this equation, remember, look at how many atoms of each element on each side. Our goal here is to have equal number of atoms for each element on each side. It is because of the law of conservation of mass. It's stated that atoms neither can be destroyed nor created in a chemical reaction. First, we need to count how many atoms on each side. Let's look at the nitrogen atoms first. On the reactant side, there are 2 nitrogen atoms. On the product side, there are 1 nitrogen atom. In order to balance this equation, we have to put a coefficient of 2 in front of the ammonia. Okay, next, let's look at the hydrogen atom. There is 2 hydrogen atoms on the reactant side, and there is 6 hydrogen atoms on the product side. So in order to balance the equation, we have to put a coefficient of 3 in front of the hydrogen gas. Okay, now let's take a look. In the reactant side, there are 2 nitrogen atoms. In the product side, there are also 2 nitrogen atoms. So the nitrogen atoms are balanced. Okay, next, on the reactant side, there are 6 hydrogen atoms. On the product side, there are also 6 hydrogen atoms. So the hydrogen atoms are also balanced. This is how you balance this equation. This is a double replacement reaction. The cations and anions switch places in this reaction. The sodium ions bond with the chloride ions, and the hydrogen ions bond with the hydroxide ions in the reaction. It is also called an acid-base reaction. Sodium hydroxide is a strong base, and hydrochloric acid is a strong acid. It's a precipitation reaction. Aqueous potassium chloride and silver nitrate react to form solid silver chloride and aqueous potassium nitrate. The solid silver chloride is the precipitate in this reaction. Remember, precipitation reaction only occurs between 2 aqueous solutions.
My name is Tina, and here is an example of a combustion reaction. A combustion reaction can be known as an exothermic reaction. Oxygen is being reacted with other compounds, producing carbon dioxide and water. In order to form a combustion reaction, and in order for it to begin, the activation for the reaction must be overcome. Often, combustion reactions are started with a flame. So if we take a look at this reaction, we have all gases for the states of matter, and we have methane, oxygen, carbon dioxide, and water. it is easy to recognize a combustion reaction because if I cover this, it would always have oxygen, carbon dioxide, and water. So let's balance this. First, we have to look at what kind of elements we have. We have C, H, and O. So I'm going to write that down. We're going to see what naked elements we have, which is the O2, so we will deal with this last. And we have hydrogen and carbons. I'm going to start with the carbons first, but before I do that, I'm going to list the amount of elements I have of each. So here we have 1 carbon, 4 hydrogens, and 2 oxygens. Here we have 1, 2 plus 1, 3, and 2 hydrogens. Okay, so first we're going to balance the hydrogens. To form 4 on both sides, we're going to have to multiply this by 2, like this. After multiplying this by 2, we have 4 hydrogen and 2 plus 2, 4 oxygens. Now, this side and this side, the left side, we only have 2 hydrogen and we want 4. So we're going to multiply the O2, the naked element, by 2 to get 4. Like that. So to double check, we have 1 carbon on each side, 4 hydrogens, and 4 oxygens, 2 plus 2. And that confirms that our equation is balanced. This is an example of a decomposition reaction. It involves the breakdown of a single compound into 2 or more elements or new compounds. These types of reactions also involve heat, light, or electricity. These energy sources break apart bonds of compounds. Here we have 3 different states of matter. The carbonic acid, which is on the reactant side, is aqueous, where ions dissolve in solvent. And the water is in a liquid state, and the carbon dioxide is a gas. We can tell that this example is balanced because we have 2 hydrogens, 1 carbon, and 3 oxygens.
Hi, this is Common. So this reaction right in front of me is a single replacement reaction. Let me tell you guys a quick story first. Single replacement reactions are a sad dating story. So for example, imagine N and the O being dating partners. And then they both go to a club. And then they meet their friend H2. But what's different in the plot twist of the story is that when they leave the club, or the party or whatever, the H and the O leave together and they leave the N alone. Aw, sad. Okay, get back to the story. How would you like balance this equation, you ask? You have to list all of the elements first. So there are 3 elements in this chemical reaction. There is the N, there is the O, and there is the H. And so how you would balance this is that you would find the amount of atoms. So on the reactant side, there is only 1 nitrogen. There are 1 oxygen, and there are 2 hydrogens. On the side of the products, the N, there are 2 of them. There are 2 hydrogens, and there is 1 oxygen. So, since the N and the H are both on only one side, you should balance those first. So let me balance the H first. If I put the H in front right here like that, there's going to be 4 hydrogens. So I'm going to have to cross this out and write 4. But to balance it, I would have to put a 2 right in front of it too. So there's going to be 4 hydrogens, so that is going to be equal. However, there's going to be 2 oxygens. So there's there's 2 oxygens here. So I have to balance it by putting a 2 in front right here to balance it out. So this would be a 2. So you have to double check to see if it's right. If I add a 2 in front of nitrogen monoxide, there'll be 2 nitrogens, 2 oxygens, 4 hydrogens, and on the product side, there'll be 2 nitrogens, 4 hydrogens, 2 oxygens, and we are done with our chemical equation. You guys are probably wondering, when is balancing equations ever going to be important? Well, in nature, plants use this process of photosynthesis. Photosynthesis is a process where organisms, but mostly plants, utilize sunlight to convert carbon dioxide and water into food, which is C6H12O6, which is glucose, and also oxygen gas. This is the equation in which photosynthesis happens. This also happens to be a redox reaction, which is when one of the reactants are oxidized and one of them is reduced. It also involves electron transfer. And also, this is a way to spot a redox reaction. There is a naked element. So for example, the oxygen here is the naked element. That's it.
So now we're going to start our very interesting lab where we will react baking soda and vinegar. So the purpose of this experiment is to explain an acid-base reaction. So the ratio, for every half a cup of vinegar, over here, we're going to add 3 tablespoons of baking soda.
Okay, so now we're gonna do the reaction. So, a cup of vinegar, and
3 tablespoons. 1, 2, 3.
As you can see, there are chemical changes. For example, there's fizzing, there's bubbling, temperature change. So it got a lot colder and changes in phase. So
let's see what happens when we mix it. So as you can see in the middle, there is a clump of the baking soda. I can see like foamy and cloudy. Yes, it got a lot more foggy. And we can hear like little bubbling sounds.
I'm not sure if you guys can hear it, but yeah, it's pretty cool. And like, you guys can use this experiment with like your science fair or like a volcano, etc. So yeah, hope you guys enjoyed it.
So what just happened in that experiment? So we have baking soda, sodium bicarbonate, and vinegar acetic acid. When these 2 chemicals react to each other, they form 2 products. One of them is carbonic acid, which is the aqueous solution. Another one is sodium acetate, which is also aqueous solution. This is also called an endothermic reaction, which heat is taken in as a reactant. That's why the temperature of the reaction is got colder.